Welcome students. We want to discuss about vector functions and two vector functions in particular, space curves and lines. So what are space curves? So to describe that, first consider the following problem. Describe the motion of particle whose coordinates at time t are given by x equals to cos t, y equals to sin t, z equals to sin t. So x equals to cos t, y is 0, z is sin t. So in this case, notice that you have x square plus z square equals to 1 and your y is 0, right? So if you look at this and in xy plane, sorry, xz plane, this will give you a, a circle of radius 1. Okay. So this thing is described by a circle of radius 1. So now let's draw the same thing in the three-dimensional coordinate plane. So this is x, this is z, yeah, not xy, but xz. So if we draw this in three-dimensional setup, we'll have, so if this is x-axis, this is y-axis, then by right-hand rule, this is going to be z-axis. So we now have a circle in xz plane because why? Because y is 0, so we are already projected into xz plane. So we are in xz plane. So and there we get a circle of radius 1. So circle of radius 1. So this is how a circle of radius 1 will look like in with y equals to 0. So this is the graph of this function. So particle basically is moving along this line. Okay. If you want to give the direction with respect to time t, we can also do that, although not necessary at the moment. At t equals to 0, you are at this point, and then you're moving along this path like that. So this is the path of your particle, right? Because if you look at it in xz plane, this is the motion. So now generalization of this idea. So you see that you get a curve here. The generalization of this idea is the parametric curve. So what is a parametric curve? So parametric curve C in a space is a triplet of a function x equals to f of t, y equals to g of t, and z equals to h of t. So they are all function of one variable, t. And the extra thing we need is that x, y, and z are continuous function of t. Here t is the parameter, and t can either come from R or t can come from some interval I. Okay, the continuous part is important so that the curve has a nice, doesn't has breaks in it. So we want a fairly nice definition for the curve, and hence we impose that. So one step further, so we can change the location of position along a parametric curve by describing it and describe that change by position vector. So the idea is that instead of writing, in this case, for example, I can write this equation here as r of t, and the position will be cos t 0 sin t. So that is the idea here, that we are the changing location of the point moving along the parametric curve can be described by giving its position vector. So r of t is either xt y yt j plus zt k, or xt comma yt comma zt. So let's look at another example, a motion of particle whose position vector is this. So we have restricted ourselves in a plane, and we have two-dimensional vectors here. So at t equals to 0, we are at sine 0 is 0, cos 0 is 1, so 1 comma 0. And then as we keep increasing t, we are moving in this direction. And then so we are moving in this direction from 0 to 2 pi. So you start at 0 is here, and then again you come back at 2 pi. We are at here. So this describes the motion of the particle, and at every point you're giving the position vector of this, say. So at t equals to 0, you are giving us this vector. We are getting this vector, which is what? Which is r of 0 is sine 0 as a vector, cos 0, which is 0, 1. So the idea is that instead of giving the points, we are giving position vector of each of these points. Okay. And they can be described by a function r of t, which is sine t comma cos t. Yeah. So we see that this is a function of t, and the output is a vector, right? So we should give it a name. Such function should be called vector-valued function, right? Anyway, so let's look at another example. Describe the motion of particle whose parametric equation, sorry, whose position vector is r of t is I cos t sine tj or tk. So first of all, to understand this, let's say what is a parametric equation for this? So for curve, finding the parametric equation is important, right? So we are interested in finding the parametric equation of the curve. So we have x equals to cos t, y equals to sine t, and z equals to t. Now notice that we get x squared plus y squared is equal to 1. So we have x squared plus y squared equals to 1. So the idea is for all values of t, for all t belonging to R, therefore this implies that this curve must lie on cylinder. So that means, so let's draw the axes. This is our cylinder. This is x-axis, y, and z. And so our curve lies on this cylinder. So so if we look at the following, so it lies on cylinder x squared plus y squared equals to 1. Now point x, y, z lies directly above x, y, 0, right? So in some sense, we are moving along the circle. So let's see. So here, when we have t equals to 0, we have cos 0 is 1. So r of 0 is, if I write it in the triangular bracket form, so I have 1, 0, 0. So I'm at this point. And then as we keep moving t, what happens is, even though we have to have a circle, x squared plus y squared equals to 1, the t is kind of stretching it out. So we have so this is our curve C. Okay, so this is the curve C. Right? Now this such a curve is called, this curve is called helix. Another way to look at this is the following. If you do not have K, if you look at, or if you look at the projection of it in XY plane, the projection of it is a circle in XY plane, right? So in XY plane, this is the projection of the curve. Now, what effect Z is giving is that if Z is basically, since Z is increasing, Z is unraveling it like a spiral. So this is the structure of this curve. Yeah, so such a thing is called helix. So parametric curves are quite interesting to draw in 3D, as you can see from this example. And now this gives us the idea of a vector valued function. So what is a vector valued function? So vector valued functions are functions whose values are vector. So in our course, we are going to restrict from uh, some subset D of R to say V3 or V2. But in general, vector valued functions are just functions whose outputs are vector. All right. So they can be from any space to space of vectors, right? So we have what is called as a vector valued function. So R of t, so for example, R of t, a vector valued function, could be a function from, say, D, some subset of R to V3, or R of t can be from some subset D of R, another D to V2. So these trace out, so these vector valued functions trace out what a curve in 2D or 3D. Well, as long as they are what? Continuous, because our definition of curve requires the continuity aspect of it. Now, so it can be viewed as position vector RT at time t moving of a moving particle along the curve C. The function R of t is also called parametrization or parametric equation of curve C. Right. So now let's look at the following problem. So find a vector equation of the curve of intersection of a paraboloid which is z equals to 4x squared plus y squared, and the parabolic center y equals to x squared. So how would we do this? Well, so the idea is what? So we want to write down, so write down R of t for this. Namely, we need x, y, and z all as functions of what? As functions of t. So if you think about it, we only need one variable, right, in this. So let's see. So we have z equals to 4x squared plus y squared, and we have y equals to x squared, and x equals to, well, x. Now this should give us an idea on what could our function be. So let's take, let x be t. If x is t, then y is going to be x squared, which is t squared, and So we have then, we get y equals to t square and z equals to 4t square plus y square, which is what? T square the whole square, which will give me t to the power 4 plus 4t square. So there we go. So our r of t is basically going to be, the first component is going to be just t. Then we have t square for y, and then for z we have t to the 4 plus 4t square. So this is a common way to write down a parametrization for this curve, and consequently the vector valued function which gives the position vector of the points, right? So what is an application? One of the interesting application is the following. Suppose you are interested to know if two curves are there, does their path crosses? And if their path crosses, does it crosses at the same time? So if it crosses at the same time, then we have a collision because both the particles will be at the same point and then they may collide. And intersect means their path intersect, but it may not be at the same point. So, okay, so then we define the following. So we have collision if two curves intersect at the same time, if they arrived at a point at the same time. So what do you mean by two curves intersecting? We are assuming a particle moving along that curve, right? So the collision, the word collision idea comes from that. There are particles moving along these curves dictated by time t, and if they intersection is when two curves intersect but may not be at the same time t. Okay, so now it is important to know these things. Why? So if two objects travel through the space along two different curves, it's often important to know whether they will collide. For example, will a missile hit its moving target? That's a reasonable thing to ask, right? The curves might intersect, but we need to know whether the objects are in same position at the same time. So let's work on the following problem, which will help us to understand how to how to solve problems like these. So suppose you have trajectories of two particles given by a vector function r1t, which is t square minus 7 12 t square, r2 is 4t minus 3 t square 5t minus 6. So do they collide? Well, if they collide, then they should arrive at the same point at the same time, right? So that means r1t should be, then this should happen for some t, yeah? Or we should say if and only if, right? This happens if and only if they, if and only if r1t equals to r2t for some t. So now the problem has reduced down to this algebraic problem. So that is t square minus 7t minus 12 t square equals to 4t minus 3 t square 5t minus 6. So now we need to solve this equation and see if there's a common solution. That is, so let's see. So we have t square equals to 4t minus 3. We have 7t minus 12 equals to t square. And we have t square equals to 5t minus 6. Now these imply t square minus 4t plus 3 equals to 0. This implies t minus 3 times t plus t minus 1 equals to 0. This implies t equals to 1 or 3. Now let's look at the next one. So we have t square minus 7t plus 12 equals to 0, which implies t minus 3 times t minus 4 equals to 0 implies t equals to 3 or 4. And let's look at this one, t square minus 5t minus 6 equals to 0. This implies t minus 3 times t minus 2 equals to 0. This leads to t equals to 2 or t equals to 3. So you see, what is common in all of them is 3, right? So therefore, at t equals to 3, r1t is equal to r2t. And that the particle at t equals to 3. Okay, at t equals to 3, they will have exactly the same path. Okay, and while you don't need to find out it will be what, but let me just write it down. 3 would be 3, so 9, 21 minus 12, so 21 minus 12, another 9, 9, and r2 3 is going to be 12 minus, so 9, 9, 5, 15 minus 6, 9. So at these points, they will have, they will be at the same point. Okay, so these particles do collide at 3, t equals to 3. All right, so now we will study a special kind of space curve, which is essentially a line. So how do we geometrically understand line? So recall what happened in 2 dimension is the same, almost the similar story gets carried to 3 dimensions, namely the following. How to find out, how do we describe line geometrically? You need one point plus, so point plus direction. Yeah, you have point and then you have to choose a direction to go to. So this will basically give you a line. Or you have 2 points, you join them and then you get a line. So line can be described by either, can be quantified, can be understood if you're given 1 point and a direction or 2 points on it. So if this is a geometric aspect of line, then algebraically, when we want to find equation of line, either of these two things should be sufficient enough. Okay, so that is what we are going to do. In this discussion, in this lecture, we are going to have 3 kind of equations of line. One is vector equation, second is parametric, and the third one is symmetric. So these are the 3 kind of equations we are going to study in today's lecture. So first, we will discuss about vector equation of a line. So let's find out how to, let's see how to derive the first equation, which is the vector equation of line. So what is given to you? You're given that a line passing through a point whose position vector is given by r0. So let r0 be position vector for position vector for P, which is x0, y0, z0. So if we draw it, this is how it's going to look like. So we have a line. Suppose we have a line like that. And this is your line L. You're given 1 point on it. So let's say point is given. Point is P0, which is x0, y0, z0. And the position vector of this point be r0. So this vector here is r0, vector r0. Now, what else are you given is that you're given the direction, which is you're given direction parallel to the line, which we call as V. So now what we want to do is we want to produce position vector of points on this line. So let's take a generic point here. And we want to find out the position vector of this point. We have r of t. So this is your r of t. And we want to find out a general formula for a general representation for r of t. So consider the following. So this part here is going to be given by some tv, right? Because these two vectors are parallel, so this will be some t times v. Yeah. So now by triangle law of vector addition, we have r of t equals to r0 plus tv. And this is true. And so every other point will follow the same thing, not only on this side, but also on the other side here. Yeah. So we get r of t equals to r0 plus tv. And this basically, so this represents p of x, y, z. Then you get position vector of x, y, z as r of t, which is r0 plus tv. So this is the vector equation of the line. Now suppose we want to suppose, so this is a vector equation. Now suppose vector v is given by a, b, c, and your r0 is x0, y0, z0. Then p of, so r of t is the position vector for p, right? So r of t, let's write that down here. R of t is position vector for p. So we get what? We get r of t, which is x, y, z in the vector format equals to r0, which is x0, y0, z0 plus tv, which is t times a, b, c. Now, if you combine these two vectors together, like multiply t with vector a, b, c, and then add them up, you get x0 plus ta, y0 plus tb, and z0 plus tc. So if we equate x equals to x0 plus a, y equals to y0 plus tb, z equals to z0 plus tc, then you get what is called as parametric equation of your line. So let's do the following problem. Write down the parametric equation of line that passes through P1 and P2. Not only just parametric equation, let's say vector equation and parametric equation. So for vector equation, we need what? So line passes through this, right? So vector V in direction of vector V if you use the same notation here as above, vector v can be written as, taken as p1, p2. So consider p1, p2. So p1, p2 is going to be -2, -1, 0, -1, 0, 2. That is going to be -3, -1, -2. So this can be your vector v. So vector v, this can be taken as vector v. Why is that? Because if you have p1, p2, if this is p1 and this is p2, your direction of line is given by p1, p2. Okay, now we need to choose any of these points as x0, y0, z0. So we can choose p0 to be 1, 0, 2, right? I mean, like any of these points can be chosen as the p0. Therefore, r of t, vector equation, is r of t equals to p0, so as a vector, so r0 of t, right? Because this implies r0 as a vector is going to be 1, 0, 2, position vector of p0, plus t times v, which we found out to be -1, -3, -1, -2. So this is your vector equation. Now what about the parametric equation? So for parametric equation, you have x equals to, or x of t rather, right? It's x is a function of t. I think that is clear, though let's spell it out anyway. 1 plus, or 1 plus -3t, 1 minus 3t, yt equals to 0 minus t, and z equals to 2 minus 2t. So this is the parametric equation of your line. So now, in R3, there are three options. Sorry, there are a few options for line. One of the option is two lines intersect. So option 1, intersect. Second option is that they are parallel. Yeah, so these two lines are parallel. Now, third option is that they are not parallel. That means the directions are not. They're not really intersect as well. So I want to draw two lines. Yeah. So this is along z equals to, say, z equals to 3, and this is x equals to 0. So these lines, these lines will not intersect. Okay. Yeah. So such lines are called skew lines. Skew lines. So if they do not intersect or are not parallel, then they are automatically skew. Now let's determine the following. Determine whether the following lines L1, L2 are parallel or skew or intersecting. So how would we go about it? So first of all, we will basically see if they are parallel, right? So V1, the direction of the first line, is 2, 2, 3. So 2, 2, 3. V2, the direction of the second line, is going to be 3, 2, 4. And since V1 is not equals to some constant times V2 for any C belonging to R, these lines are not parallel. So they are not parallel. Okay, so not parallel. Now, next thing we want to do is to check if they intersect. But now we want to intersect. So think about t as time. They may not intersect at the same time, right? So what we should do is we should take one of them as x. So that is 2t equals to 5 plus 3s. Then we have 1 minus 1 plus 2t equals to 1 plus 2s. And then we have 3 plus 3t equals to 4s. And see if they intersect. So they intersect if is true for some s and t. So let's work that out. Is it true for some s and t? So we need to solve these equations simultaneously and see if they have any solutions. So we can basically play with these two guys. So if we do equation 1 minus equation 2, so 1 minus 2 gives us, subtract, we get 1 equals to 4 plus 4 plus s. So this gives us s equals to -3, and that would give us if we substitute in this equation, we'll get 2t equals to 5 minus 9. This gives us t equals to minus, so 5 minus 9 is -4, so this will be -2. So let's check if the simultaneous solution satisfies the third. So star sub star in 3 to check if it is satisfying the third equation as well. We get LHS equals to 3 plus, or 3 times 3 minus 2, which is 3 plus 3 minus 2, which is going to be -3, whereas RHS is going to be 4s. So is 4 times -2, sorry, 4 times s, right? So 4 times s is -3, which is 12. So LHS is not equal to RHS. This implies these lines do not intersect. And then hence from 1 and 2, so from 1 and 2, 1 and 2 implies these lines are skew. These lines are skew. So similarly, all this problem can be worked out as well. What you have to do is you have to check, first of all, they are not parallel. You can see that right away. Why? Because the directional vectors are not multiple of the other. So they're not parallel. So what you have to do is you have to check if they intersect. If they intersect, then well, they intersect. Otherwise, they will be skew. Okay. So now the third equation for the line is called symmetric equation. So what do we have? We have x equals to x0 plus at, keeping the usual terminology, y equals to y0 plus bt, z equals to z0 plus ct. Yeah, this is what we found out there. Now suppose a, b, and c all are not zero. In that case, if we try to eliminate t, what do you get? We get x minus x0 by a equals to t. Then here we get y minus y0 divided by b equals to t. And z minus z0 divided by c equals to t. So if you equate all these t together, you get what is called a symmetric equation of line. Okay, now what happens if one or more of them are zero? Of what is zero? If one or more of a, b, or c is zero. So let's consider the case one. A is zero, b and c are not zero. So in that case, what will happen is you will get here or here will get x equals to x0, right? We can't eliminate it. We will get y minus y0 by b to c. So this basically becomes your symmetric equation. Now similar can be worked out when what? When two of them are zero. Well, if all three of them are zero, that is not a possible. That will not give you a line, right? Okay, so now let's consider the following. Uh, find the parametric and symmetric equation of this line. So let's find the parametric and symmetric equation of line that passes through point 1, 2, 3 and minus 1, 1 and minus 2. At what point does these line intersect, sorry, does this line intersect xz plane? So, well, I mean, you have, first of all, we can find a, b, and c. That is same as your vector v, and that is going to be, so you have points p, so let's call this as p and q, pq. Then this direction will give you the direction of your line, which is v. So when you compute this, so we can get this to be qoq minus op, or if I subtract, you'll get minus q is this guy, so minus 2 minus 2 1 minus 2 minus 1 2 3, and then we get minus 2 minus 1, which is minus 3, minus 1 minus 2, which is minus 1, minus 2 minus 3, which is minus 5. So this is our v. And x0 y0 z0 can be taken to be any of these points. Well, let's take 1, 2, and 3. Now, in this case, we will have, therefore, parametric equation. So parametric equation is given by x equals to x0 plus at, which is going to be 1 minus 3t. Similarly, y equals to y0 plus bt, which is going to be 2 plus minus t, so 2 minus t, and z equals to z0 plus ct, which is going to be 3 minus 5t. So this is a parametric equation of your curve, and and then the symmetric equation is given to be, symmetric equation will be given by symmetric equation is x minus x0 by x minus x0, which is 1, divided by the direction, which is minus 3, y minus y0, which is 2, divided by direction, which is minus 1, component, minus, so z minus z0, which is going to be minus 3, divided by minus 5. If you want, you can get rid of these minus signs as well. That's also okay. So this gives you a symmetric equation of the line. So now, at what point does this plane intersects the xz? Does this line intersects the xz plane? So what is the property of xz plane? So let's see. So we have x, y, and z. So this is our xz plane. Now, what is the property of xz plane? If any line passes through this xz plane, at this point, what should happen? Y equals to 0, right? So when is y 0? Y is 0 when 2 minus t equals to 0, which means that t equals to 2. So therefore, the point is x equals to 1 minus 3 times 2, y equals to, well, should be 0, and z equals to 3 minus 5 times 2. So the point is, required point is minus 5, 0, and 3 minus 10, which is minus 7. Minus 7. So this is the point of intersection. So thank you for your attention.